These notes are for section 8.2 in your book, Arithmetic Sequences and Series. This is what we did in class on Friday. So some things that we need to know first are the explicit formula for an arithmetic sequence. If a sub n equals a sub 1 plus b times n minus 1. I'll zoom in just a little bit. In that formula, a sub 1 is the first term of the sequence. B is the common difference between consecutive terms, and n is the number of terms. Okay, so let's get some practice on writing the equation when we're given a sequence, and we're going to find what the 12th term of the sequence is after we find what the equation is. So the first thing that we need to do is we need to find the common difference d. In order to do that, you need to take two terms, one term and its previous term, and you're going to subtract it, and the common difference is 4. So what you should do for, especially when you're taking your quiz and when you're going to take your test, I would double check to see that all of the terms in the sequence, the common difference is 4. So 12 minus 8 gets us 4, and 16 minus 12 also gets us 4. Okay, so this means that it's an arithmetic sequence because the common difference is equal between each term. So now that we know that our common difference is 4, we actually have our difference and we have our first term. Okay, so we are going to plug this into the formula for the explicit formula for the sequence. A sub n equals a sub 1 plus b times n minus 1. So we do not know what our last term is. We know our first term of that sequence is 4. And we know that our difference is 4. We don't know the number of terms. So we're just going to simplify this. So our explicit formula for this sequence is a sub n equals 4n. So this was our step 2. We have to find equation for a sub n. Okay. Now our third step will be to find what a sub 12 is for our 12th term. Okay, so I'm just going to plug in 12 right at the end. So 4 times 12, I guess that's 48. So our 12th term of that sequence is going to be 48. Okay, so for this second example, we have the terms 26, 18, 10, and 2. So the first thing we need to do is we need to find the common difference. So we take one term and subtract away the term before it. So 18 minus 26 gets us negative 8. And to double check, 10 minus 18 gets you negative 8, and 2 minus 10 gets you negative 8. Okay, so now we're going to find the equation for a sub n. Okay, and I'm writing that out. You should write out the formula each time too, especially when you're doing your homework, because the formula for the sequence needs to be memorized. Okay, so we're going to plug in all of our known values. So our first term is 26. Our difference is negative 8, so I'm going to write negative 8 times n minus 1. And now just simplifying, 26 minus 8n plus 8. So that gets us our formula, negative 8n plus 34. Okay, so the third step, we are finding our 12th term of the sequence. So a sub 12 is going to be negative 8 times 12 plus 34, which is negative 62. Okay. So now this example, we are going to find the nth term of the sequence. So that means that we need to find out what the formula is for our sequence. What they give us is they give us the 8th term, and that term value is negative 20. and the 17th term, which is negative 47. If you've noticed, the equations that we found for the two previous examples, and this is true for all arithmetic sequences, the function is a linear function. So that really means that the coefficient in front of the n here and the coefficient in front of the n here, the 4 and the negative 8, are really the slope of the line. So we can treat this particular example like we're finding when we're finding the common difference to find the slope of the line. So we can pair together 8 and negative 20 and 17 and negative 47 and make it like a coordinate. So when we find the common difference, we'll do negative 47 minus negative 20, or negative 47 plus 20, over 17 minus 8. And that works out to be negative 3. Okay. Now, this is where what we're about to do is a little bit different from the previous example. We don't know what our first term is in the formula. A sub n equals a sub 1 plus b times n minus 1. Okay? But what we can do is we can plug in our 8th term, or we can plug in the 17th term into a sub n, and then we could also plug in whatever the term value is into n. So we're going to choose to plug in the 8th term. So our 8th term value is negative 20. We don't know our first term. Our common difference is negative 3. And our term number is 8. So we're going to have 8 minus 1. So this is negative 20 equals a sub 1 minus 3 times 7. Okay, and when we solve for a sub 1, we are going to get 1. Okay, now we know our first term, and we know what our common difference is. So we can find our nth term. So we're going to find a sub n. So a sub n equals a sub 1 plus b times n minus 1. And that's going to be a sub n equals, our first term we found was 1, plus our common difference is negative 3. I should have wrote minus 3 there, times n minus 1. So a sub n equals 1 minus 3n plus 3, which simplifies to negative 3n plus 4. So that is our formula for the nth term, given two different terms in the sequence. Okay. This example here asks us to find n if we know our first term is 2, and we know a sub n is 74, and our common difference is 3. So all we need to do here is we need to plug in our known values into the formula. Okay, we know a sub n is 74. Our first term is 2. Our difference is 3, and we don't know what n is, so we can't substitute anything into there. So now I'm just going to simplify. Okay, so that means if our nth term is 74, the term value must be 25. So it's the 25th term of that sequence. Okay. Sorry about the glare. I should shut the blinds, but. So now we're going to talk about our arithmetic series. These two formulas need to be memorized. They are the formulas that are used to find the sum of a series. So the first one is used when you know your first and your nth term. Okay. And this second equation here is when you're going to, when you only know what a sub 1 is. But you need to find the nth term, a sub n. Okay. Now, these two are very similar to each other. The way that this formula comes about is a sub n, so I'm just going to rewrite this formula down below. Okay, we know that our explicit formula for a sub n is, so we're going to add a sub 1 plus d times n minus 1. So when I combine these together, that's where that 2a sub 1 comes from. So it might just be a little bit more easier for you to remember the first one and know what a sub n is so that you can derive the second formula from it if you need to use it. If not, that's totally okay. Okay, so just some examples down below that I'm going to do to explain where this formula comes from. If we have this series or the sequence 4, 8, 12, and we have 16. Okay, so this formula says that we're going to add the first and the last term together. So down here, if I add the first and the last term together, I have 20. If I add together the two inside numbers, 8 and 12, I also get 20. So I have two groups of 20. Okay, so do you see how we have the n over 2? I have 4 terms here, and I have 2 groups. So I was taking the 4 and dividing it by how many groups there are, and then multiplying it by the sum of the first and the last. Okay, and we can do another example. If we had 4, 8, 12, 16, 20, and 24, I have 1 group of 28, 2 groups of 28, 3 groups of 28. So I'm multiplying 3 by 28. I would figure that out. Okay, so just relating it up here, I had 6 total terms down here, but I had 3 groupings of them. So that's how we get the n over 2, so it'll be 3, and then multiplying it by the sum of the first and the last term. Okay, so let's do a few examples. So finding the sum of the first 16 terms of the following series. Okay, so for this one, we know our first term is 5. But unfortunately, we don't know what our last term is. We don't know our 16th term. So we have to find that. So what we're going to do is we're actually going to use that second formula on the last slide, where we are going to have, and I'm going to rewrite it like this using the second way. S sub n equals n over 2 times a sub 1 plus a sub 1 plus d times n minus 1. Okay. So what we're going to have is we know what a sub 1 is. We don't know what d is, but we can find that very easily. We take 7 minus 5 and we get 2. And just to check, 9 minus 7 also equals 2. So now we're going to plug everything in. S sub 16, because we were finding the sum of the first 16 terms, equals 16 over 2. Okay, and we're going to have 5 plus 5 plus 2 times 16 minus 1. Okay, and this is going to be 8. This is 10 plus 2 times 15 is 30. Okay, so we're going to have 8 times 40, which equals 320. So the sum of the first 16 terms is 320. Okay. Now the second example, 82, 77, 72. We know our first term is 82. Okay. We don't know the 16th term. Okay, but as you saw over here, we had to figure out what our common difference was in order to use the sum formula. So our common difference here is going to be 77 minus 82 gets us negative 5. So I'm just rewriting the sum formula. Okay. So we're finding the sum of the first 16 terms. So S sub 16 is 16 over 2 times 82 plus 82 minus 5 times 16 minus 1. Okay, so this is going to be 82 plus 82 is 164 minus 5 times 15, which is going to be 75. So now we're going to have 8 times 164 minus 75, and that equals 712. Okay, so a few examples ago we were asked to find n knowing what our given information, we plugged it into the sequence formula, okay, but now we're going to find the number of terms for a series. So we have our first term is 4, we know our common difference is 3, and our last term, S sub n, or sorry, the sum of our terms, S sub n, is 246. Okay, so what we need to do is we need to first write down our formula for S sub n. Okay, the first step that we're going to do is we're going to sub in the known values. Okay, we know that the sum is 246. Okay, we don't know what n is. Okay, so we're going to have 2 times our first term, which is 4, plus 3 times n minus 1. So all of the n's are staying as is because we're trying to solve for them. Okay, so let's just simplify as far as we can go. 246 equals n over 2 times 8 plus 3n minus 3. So this is 246 equals n over 2 times 3n plus 5. Okay, here I would choose to multiply both sides by the 2 so that I'm not dealing with distributing a fraction. So this will be 492 equals n times 3n plus 5. Okay, so here you should notice that you're going to get a quadratic because we have a squared term here. So what we're going to need to do is first set our equation equal to 0. So this is our second step. So we'll have 0 equals 3n squared plus 5n minus 492. Okay, I'm just going to go right here. Okay, so our third step would be to factor and solve. Or you can graph and find the intercepts. Okay, regardless of which way you do it, okay, you're going to get 2 different answers. N equals 12 and n equals negative 13.6 repeating. Okay, so now you need to check your answers to see which one makes sense. Obviously, n equaling our number of terms equaling a negative value does not make sense in this case. So our answer for a number of terms in this sequence where our sum is 246 will be 12 terms. Okay, and let's do one word problem together. So we're going to apply the sum formula. The auditorium has 20 rows of seats. There are 20 seats in the first row and 1 additional seat in each consecutive row. How many seats are in the 20 rows? So first we need to find from the words what kind of information we know already. Right? We know that there are 20 seats in the first row. So A sub 1 is going to be 20. Okay? And then they tell us that each additional row, or each consecutive row, sorry, has 1 additional seat. So that means that the common difference is going to be 1. And they want to know how many seats are in the 20 rows. So we're asked to find the sum of the first 20 terms. Okay? In order to find the sum of the first 20 terms, in addition to knowing our first term, we have to know what our 20th term is. Okay? So that will be the first step. We need to find what A sub 20 is. Okay, so we're going to use our explicit formula for our nth term. A sub n equals A sub 1 plus V times n minus 1. Okay, we're trying to figure out our 20th term. Oh, should be 20 here. Plus 1 times 20 minus 1. So A sub 20 is 39. Okay, and our second step here, now that we know that this is 39, is to find the sum of the first 20 terms. So S sub 20 is going to be equal to n over 2 times A sub 1 plus A sub 20. Okay, so this will be 20 over 2 equals 20 plus 39. When you simplify that, you're going to get 590 seats in the first 20 rows. Okay, so that's the end of this lesson. You can refer to School Fusion or to your unit calendar to see what the homework assignment is. It is on page 573. So that's going to be due next class.